this section of Chapter 11, we're going to look at specific reactions that will alter the carbon skeleton. So one of the reactions is to take a terminal alkyne and react it with an alkyl halide. Remember that proton that's on the end of our terminal alkyne is slightly acidic, so we can deprotonate it with a hydride. Remember, the hydride is that H with 2 electrons and a negative charge. We can then take this alkanyl ion and we can react it with an alkyl halide. Remember that alkyl halide needs to be sp3 hybridized because we're going to be looking at an SN2 mechanism. So looking at our reaction, we would have once again that terminal alkyne, so it would be on the end of our carbon chain. We're going to react this with a hydride, so I'm going to show a sodium hydride. This will then deprotonate that the alkyne to produce the carbanion. From here, we can react that anion with an alkyl halide. And again, this would be through an SN2 type mechanism to form a new carbon-carbon bond. And now our alkyne will be an internal alkyne. So if we look at this based on our mechanism, we would start off with our typical acid-base chemistry, where we have that hydride behaving as a base to pick up the acidic proton on the end of our terminal alkyne. This will leave us with our anion as well as hydrogen gas. From here, we can introduce that alkyl halide. Again, please remember it does need to be sp3 hybridized so that we can do our SN2 mechanism that we have been looking at in our previous chapters. And again, this will now lead us to an internal alkyne, and we would have our halide. Another route that we can form and alter our carbon skeleton by adding more carbon atoms is through the use of the cyanide ion. So remember, the cyanide ion is the Cn- ion, and we'll be forming a new bond between our carbon chain and the carbon of the cyanide ion. We can then use this cyanide ion, or this Cn group, to be converted into other functional groups later on down the line. So again, based on our reaction, we're going to start with an alkyl halide, and we'll have our cyanide ion. And again, we're going to go through our typical SN2 type mechanism, where we're going to substitute that cyano group for our halide. So once again, the mechanism is going to be our typical SN2 mechanism. So remember, with cyanide, we do have a triple bond between the carbon and the nitrogen. Both the carbon and the nitrogen have a lone pair, and the carbon would have the negative formal 1 charge. So the negatively charged carbon will come in as the nucleophile, causing our leaving group of the halide to leave. So once again, our typical SN2 mechanism, leaving us with our new cyano group on our carbon chain and our alkyl halide.